Greetings of the day. I'm Dr. K. Raghuram Mohan Reddy. The course name is Unconventional Machining Process. The topic is electro discharge machining and material removal mechanism of electro discharge machine. I'm Dr. K. Raghuram Mohan Reddy, professor in Department of Mechanical Engineering. So the course outcome is understand the working of electro discharge machining process. So at the end of this session, student will be able to understand the working of electro discharge machining process. Right, before we going to directly the electro discharge machining process, let us come from non-traditional machining process. In that, there are mainly three types: mechanical, thermal, chemical, and electrochemical. Okay, right. So far we have covered the mechanisms or techniques or machining process which are under mechanical. Now let us start with thermal electro discharge machining. Okay, right. Right. This is electro discharge machining schematic working principle. Right. See here, this is spark zone, workpiece, okay, dielectric fluid, tool holder, servo control feed, DC pulse generator, filter, and pump. Okay, so here dielectric fluid medium will pass over the workpiece constantly through this pump and filter setup. Okay, so here the workpiece is fixed to the fixer which is on the table. Okay, so in electro discharge machining process, the beam of electrons will strike the workpiece and the workpiece will move in X, Y, Z directions on the table. Okay, so this is the schematic diagram. Okay, now we will see each and every parameter of it. Right, so here workpiece will be this one. So power source will be given. Okay, so positive is connected to anode and negative is connected to cathode. Okay, so when anode and cathode comes together, spark will exist. Okay, see here the sparking that we can see. Right. Parameters affecting electro discharge machining performance. Okay, so here the important one is greater volume. Okay, so dielectric properties, pulse characteristics, again workpiece thermal properties, tool electrode parameters, material removal rate, surface quality, and accuracy. Okay, so under workpiece thermal properties, melting point, boiling point, conductivity. Okay, these three parameters affect from this workpiece thermal properties. Next, tool electrode. So material of the tool electrode and its movement and its wear. So these are the parameters affecting the EDM performance. Now let us see in detail all these parameters, how affected. Okay, first let us see electro discharge machining. Okay, it is a non-conventional machining process, particularly used for brittle and hard materials. Okay, which cannot be machined by any other process of conventional machining process. Okay, the other names also called spark eroding, spark machining, wire erosion, wire burning. So these are the other names of the electro discharge machine. Right. So working and few parameters under working principle. It is a process of metal removal based on the principle of material removal by an interrupted electric spark discharge between the electrode tool and the workpiece. Okay, so here electrode tool and workpiece. Right. In EDM, a potential difference is applied between the tool and workpiece. Okay, so this is workpiece, this is tool. Okay, so beam of electrons will strike over the surface of the workpiece, and this workpiece will move in x, y, and z directions. Okay, so that the material removal will take place. Both tool and work material are to be conductors. So this is essential. Okay, otherwise the electrons will not pass. Okay, so here the electrons need to be transferred from cathode to anode. So for that, both the materials to be conductors. Right. Next, the tool and work material are immersed in a dielectric medium. Already in the working principle we have seen in the schematic diagram. Okay, so both the work and tool are immersed in a dielectric fluid medium. Next, deionized water used as the dielectric working and parameters. A gap is maintained between the tool and the workpiece. Already I told you, I'll show here. See here, there is a gap between tool and the workpiece. Okay, right. Depending upon the applied potential difference, that is 50 to 450 volts, and the gap between the tool and workpiece, an electric field would be established. Okay, so without gap, there would not be electric field establishment. Right. Next, generally the tool is connected to the negative terminal, that is cathode of the generator, and the workpiece is connected to the positive terminal, that is anode. Okay, so this is workpiece and this is tool. So tool is connected to negative terminal, the workpiece is connected to positive terminal. Okay, so here tool can be cathode and the workpiece can be anode. Okay, always there must be a gap between the tool and the workpiece to generate electric field. Okay, next here both the tool and workpiece must be conductors, and the tool and the workpiece must be immersed in the dielectric fluid medium. Okay, one more point we have to make a note. Here both tool and workpiece must be conductors, and tool and workpiece must be immersed in dielectric fluid medium. Okay, as the electric field is established between the tool and the job, the free electrons on the tool are subjected to electrostatic forces. Already we have discussed that there must be a gap between tool and the workpiece. Okay, so the free electrons on the tool are subjected to electrostatic forces. Right. If the bonding energy of the electrons is less, electrons would be emitted from the tool. Right. Such emission of electrons are called or termed as cold emission. Okay, this is very important. Okay, so because of the free electrons of less bonding energy are striking the workpiece, and the emission of electrons are called cold emission. Right. Next, the cold emitted electrons are then accelerated towards the job through the dielectric medium. Okay, these cold emitted electrons are then accelerated towards the job through the dielectric medium. Right. Next, as they gain velocity and energy and start moving towards the job, there would be collision between the electrons and dielectric molecules. Such collision may result in ionization of the dielectric molecule. Okay, ionization depends on the ionization energy of the dielectric molecule and the energy of the electron. Okay, so here the phenomena of electro discharge machining is similar to laser beam machining. Similar to laser beam machining, the pool of electrons strike the workpiece so that the material removal will take place. So because of the kinetic energy of the electrons, the material removal is taking place. So that kinetic energy is converted into heat energy. Because of that heat energy, the vaporization of material will take place such that the material removal will occur. Okay, right. As the electrons get accelerated, more positive ions and electrons would get generated due to collisions. This cyclic process would increase the concentration of electrons and ions in the dielectric medium between the tool and the job at the spark gap. Already we mentioned that there would be a gap between tool and the workpiece. Right. The concentration would be so high that the matter existing in the channel could be characterized as plasma. Okay, here the zone at the fusion or the melting occur at the workpiece is because of this plasma. Okay, right. Next, the electrical resistance of such plasma channel would be very less. Thus, all of a sudden, a large number of electrons will flow from the tool to job and ions from the job to tool. Okay, so here this is workpiece, this is tool. Okay, so electrons will flow from tool to workpiece and the ions will transfer from workpiece to tool. Okay, so this is called avalanche motion of electrons. Such movement of electrons and ions can be visually seen as a spark. Okay, so the movement of electrons and ions can be visually seen as a spark. Thus, the electrical energy is dissipated as the thermal energy of the spark. That's what we have discussed. The high intensity or high kinetic energy of the electrons are converted into heat or thermal energy so that the surface or interface of the workpiece will melt and the material removal will occur. Right. Next, the high-speed electrons then impinge on the job and the ions on the tool. Already we have discussed. The kinetic energy of the electrons and ions on impact with the surface of the job and the tool respectively would be converted into thermal energy or heat flux. That's what we have discussed. Okay. Such intense localized heat flux leads to extreme instantaneous confined rise in temperature, which would be in excess of 10,000 degrees centigrade. So at this 10,000 degrees centigrade, any metal can be melts and vaporization will occur so that the material removal will take place. Okay. So such localized extreme rise in temperature leads to material removal. This is obvious because it is 10,000 degree centigrade of temperature. Material removal occurs due to instantaneous vaporization of the material as well as due to melting. Okay, already we have discussed. The molten metal is not removed completely but only partially. So here the dielectric fluid medium will circulate and the tool and the workpiece are completely immersed in the dielectric medium. Okay, right. Right. EDM VI parameters. voltage current parameters. See here, dielectric medium. Here job is considered to be positive, that is anode. Tool is considered to be cathode, that is negative. Okay, right. Right. Here voltage is constantly rise, okay, and constant, and will come down. But here come to current, it is just narrowly increased, okay, constantly increasing, and it is constant to some extent, and so it is straight one, it is a taper one, we can see clearly. Right. Regarding spark description, so these are the parameters. So how the material of the workpiece is vaporizing or melting, that we can see here. Okay, so this is tool, this is workpiece. Okay, plasma channel, this one, this is dielectric flow between workpiece and the tool. Of course, both tool and the workpiece are completely immersed in dielectric fluid medium. Next here, vapor. Okay, so vapors will come to extreme positions. This is solidified metal, and at this stage we can see liquid metal. So this is heat affected zone. This is recast layer. So here arc crater that we can see here. Right. So you can see clearly the positives and negatives. Okay, anodes and cathodes. Okay, you can see clearly. Positive ion is attracting towards tool, and this negative one is attracting towards workpiece. Okay, so electrons are towards workpiece, and the positive ions are towards tool. That's what we have discussed. Right. Regarding variation of voltage with time using RC generator. Okay, right. Here power and control circuits of electro discharge machining. Okay, so this is about charging time, this is about discharge time. So discharge time is very less, so this is voltage, this is cycle time. Okay, so this is an arc like curve, and this is straight curve, straight line. Okay, right. Next, power and control circuits with respect to current and time. Okay, so earlier one is voltage and time. Now this is current and time. So this is average current, this is peak current. Okay, so on time, this is called 1 cycle, this is off time, on time, off time. Okay, right. During on time, it will rise, current rise, and current will become 0 during off time. Okay, and this is called one cycle. That means from one peak to next peak. Okay, the distance between the starting of one on time to the next on time. Okay, right. Periodic discharge in RC type generator. Okay, so here this is voltage, this is current. Okay, so this is periodic discharge in RC type generator. Okay, right. Next, voltage and current waveforms during EDM. See here, on time, off time. Okay, and this is called one cycle. During one cycle, that means from on time to off time. Okay, how ionization curve is there, and this is breaking voltage, this is spark volt. Okay, so this is what ignition delay. Right, when you come to current, this is peak current, this is average current, and xx represents time. Okay, this is called spark energy. Okay, so in current we have spark energy. Again in voltage we have ionization process. Okay, right. Right. Basic characteristics of electrode materials. The basic characteristics of electrode materials are high electrical conductivity, electrons are cold emitted more easily, and there is less bulk electrical heating. Second one, high thermal conductivity for the same heat load. The local temperature rise would be less due to faster heat conducted to the bulk of the tool and thus less tool wear. Okay, regarding electrode material, the following are the different electrode materials which are commonly used in industry. Graphite, electrolytic oxygen free copper, tellurium copper, that is 99% copper plus 0.5% tellurium, and remaining 0.5 all others. Next to brass. These are the tool materials. Okay, all these are conductors. Okay, electrode means tool. Right. Regarding dielectric medium. So the following are the important functions of the dielectric medium. Insulates the gap between the tool and work, thus preventing a spark to form until the gap voltage are correct. Second one, cools the electrode workpiece and solidifies the molten metal particles. Third one, flushes the metal particles out of the working gap to maintain ideal cutting conditions, increase metal removal. These three are the functions of dielectric fluid medium. Okay, so it insulates the gap between the tool and the work, and cools the electrode and workpiece, flushes the metal particles. Okay, right. So these are the references. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.